Okay. So anytime there's a net force, then obviously the object's going to accelerate. So we've got this fairly simple Newton's second law question here about this lacrosse player. And it tells me that the lacrosse player exerts an average net horizontal force of 3 newtons forward on a 0.15 kilogram lacrosse ball. Okay, they just told me the net force. Do I have to do like even a free body diagram or anything? No, they told me what the net force was, which is what we were calculating in the quiz question, the net force. Okay, so all I have to do here is write F net equals 3.0 newtons forward. Okay, and they tell me the mass, 0.15 kilograms. Okay, and we are looking for the average horizontal acceleration of the ball. Okay, is this a fairly straightforward question? What formula am I going to use? Right, this one. Okay, that's the way it looks on your formula sheet. Okay, F net equals m times a. I'm looking for a, so I'm just going to divide both sides by m. All right, and then plug in my numbers. So that'll be 3.0 newtons divided by 0.15 kilograms, which is going to leave me with 20 meters per second squared forward. Okay, that is about as easy as a Newton's second law problem will ever be for you, because you didn't have to draw a free body diagram. You didn't have to really do any vector sum of all forces because it was already given to you. Okay, I'm not going to be that nice most of the time. Okay. All right, questions on how that one worked? Okay. I would like you guys to try these two. They're similar to the one that was on your quiz and kind of similar to this one. They're pretty straightforward. There's not a lot of calculations involved with these two. Okay, answers are here in brackets. You can check them as you go. For the first one here, okay, they're telling us the net force is 12 newtons to the left. Okay, so they told me F net, okay, 12 newtons left. They told me the mass, 6 kilograms, and they're looking for the acceleration. So F net equals m times a, and I'm just manipulating for a. Okay, so F net divided by m gives me 12 over 6, 2.0 meters per second squared left. Okay, now vectors are important here. That's what people forget in this unit all the time. Last unit was all about vectors, vectors, vectors. People don't forget. But in this unit, it's easy to miss those. Okay, and then for number 2, just the opposite manipulation. We're looking for m instead. So we would have F net over a equals m for that one. They told us the net force was 34 newtons. And we're dividing that by the acceleration, 1.8 meters per second squared. Okay, that's going to leave us with kilograms for the units, and it's going to be 19 kilograms. Okay, everybody all right with that? Any problems with any of those? Okay, because what we're going to do is kind of build on this throughout the day, and we're going to get into more and more kind of in-depth, comprehensive kind of Newton's second law problems. Okay, so this one, you're going to need a free body diagram. There's more than one force involved here. We're not just being given the net force in this question. Okay, this is also going to start introducing problems where there's a lot of words. Okay, and it becomes like a reading comp exercise, which is like nightmarish for me, as it is for you, I'm sure. Okay, but you have to be able to pick out of that story the information that you need in order to solve the problem, so that when you get to Physics 30 on the diploma exam and you have to read an entire page of text to answer one question, okay, you can do that, right? Because I kid you not, that actually happens. Right? It's pretty crazy. So there is a bit of a trick to this one if you're not paying attention to the question. Okay, when I'm drawing the free body diagram here, this is the canoe, because everything is a square in this unit. Okay, but that's a canoe. What mass do I write in there? 135 kilograms. Why? Right, both rowers are in the boat. It's really easy to miss that in the question, but like, I don't know how else you row the canoe if you're not in it. Okay, but the most common mistake on this question is put 20 kilograms in there because the question says the mass of the boat is 20 kilograms. But there's guys in it, okay, that are actually doing the rowing, and we can't forget about them. Their mass contributes to the total mass of this system. Okay, so when we're dealing with something like this, we actually call it a system because it's a few masses that are in there at the same time.
Wouldn't it be 155 then?
Yeah. Sorry, is it 155?
Yeah.
Sorry, I don't have my calculator, and I shouldn't do math in my head. So yeah, 155. Okay, so 65, okay, 85, yeah, 155. 155 kilograms is my total mass. Okay, and then I've got to put on all of my forces. So athlete A rows with 400 newtons forwards. Athlete B rows with 420 newtons forwards. Okay, and then we have a resisting force of 380 newtons. All right. So I have my free body diagram. What do I use it to calculate? Net force, vector sum of all forces. Okay, so I'm going to have 820 newtons forward minus 380 newtons backwards. What does that come out to? 440. 440. Okay, so we're going to have a net force. So F net is going to be 400 plus 420, okay, minus 380, giving us 440 newtons forward. Okay, so did I just do the vector sum of all forces? Do I always do vector sum of all forces and m times a? I haven't done m times a yet, have I? Okay, but that's all right, because that's the next thing. They want the acceleration of the canoe. Well, acceleration is F net divided by m. So we take our 440 newtons and we divide it by the 155. Okay, what does that come out to? Can you make me walk over and get my calculator? 2.6 meters per second squared. Okay. And that'll be forward. Again, got to have that vector on the vector quantity.
It's 2.8.
Is it 2.8?
Yeah.
Sorry. Sorry, I have been working on the licensing situation for my calculator. I don't know why that wasn't taken care of previously, but okay, it doesn't. I'm sure every other person who uses that is right now really screwed because no one has it working. Okay. All right. Questions on that one? Okay. There's another one. Got to read it carefully. There is some extraneous information. Okay, that means there's information in there that is not needed and in fact would be detrimental if you used it in your calculations. Okay, read it carefully, give it a try. All right, so we're reading through this question. Okay, in the men's four-man bobsled, the maximum mass of the bobsled with two riders, a pilot, and a brakeman is 630 kilograms. So, that's completely useless trivia. I don't need that number at all. Why don't I need that number? Because during this question, the two guys are not in the bobsled. They're pushing it. Two of them are in there, but the other two are not in it. Okay? This is not the mass of this particular team. So that number is irrelevant. It's just there to distract me. Okay? I actually don't need that number. Okay? During a practice run, riders A and B exert average forces of 1,200 and 1,220 newtons each to accelerate the bobsled, which has a mass of 225 kilograms, a pilot, and a brakeman, whose masses I also know. What do I have to do with those three masses? I have to add them up. That's how much mass is being pushed by the two pushers, and that's all they are. Okay, the last two guys in the bobsled, that all they are two really strong guys who just push real hard. Okay, they probably were like sprinters who just weren't fast enough, but were really, really powerful. Right? This is what happens in the bobsled. Like if you're a sprinter, but you don't have good enough top speed to win, you become a bobsled pusher, okay? Because it's all about power. Like the people who have the best 40 are really good at the bobsled because they're all about power and they can just push really hard. They don't have to run really fast, they just have to push really hard, okay? And so the two guys are not in, they're just pushing. Two guys are already in, two guys are not. Okay, so when I'm calculating the total mass of the bobsled, okay, I'm going to have the bobsled, 225 kilograms, plus 98, plus 97, okay, giving me a total mass of 420 kilograms, okay, being pushed by the two pushers. Okay. Then I'm going to put the two pushing forces on there, 1,200 newtons forwards and 1,220 newtons forwards. Okay, then they jump in for the challenging ride down a 1,300 meter course. Do I need that number? Also extraneous. It's just there to distract me. I have nothing, distance doesn't matter here. I'm not being asked to calculate the acceleration using the acceleration formula. I'm being asked to calculate it using the force formula. So, during the pushing, the magnitude of the force of friction on the sled is 430 newtons. Okay, I've got my free body diagram done. Are these forces all collinear? So I don't need to draw a vector diagram, right? Because they're all collinear. So I'm going to do vector sum of all forces. F net equals 1,200 plus 1,220 minus 430, okay, which would give me 990? 1,990, right? Don't do it in your head. Do it in your head. I was right. 1,990 newtons. Okay. Okay, so 1,990 newtons is my net force, and that's forward. Okay, can I calculate the acceleration now? Again, because I know the net force and I know the mass. Okay, so acceleration will be 1,990 newtons divided by 420 kilograms, which will give me 4.7 meters per second squared forward. Okay, so it's a question that you have to make sure you read carefully because there is stuff in there that is designed to throw you off and get you to use numbers that you don't actually mean. Okay, that comes up a lot in physics. Okay, it's a dirty trick, but it's there. Okay, we're going to look at elevator questions. Elevator questions are a very typical type of question in Newton's second law, right? So I'd like you to write down this example question, label it elevator question because elevator questions come up all the time. Okay, so the reason an elevator goes up or down is because it's being pulled by a cable. And some sort of motor is pulling it, okay, from above. Whether it's going up or down, there's a motor pulling it up. Okay? We don't want to ever have a situation where that motor is not involved, because if it's not, what is the elevator going to do? It is going to free fall because of. Okay. What do you suppose the most commonly forgotten force is in an elevator question? Gravity. Okay. Not in an elevator question like this. Nobody forgets in an actual elevator question that gravity is involved. Okay? But if I give you a question like this, where I say, I take a marker and I throw it up in the air with a force of 25 newtons, what's its acceleration? Is there another force acting on the marker? Gravity. But everyone forgets it when I say I'm throwing it up in the air. There's, oh, well, you're pushing on it. That's the only force. No, it's not. If that was the only force, this thing would go forever. Okay? I'd put it in orbit and beyond. Okay? Because there'd be nothing to slow it down. There'd be no gravity. You got to remember, in any situation where the object is moving vertically, it's an elevator. Okay? So this is a very wide range of questions, okay, that we kind of group into one thing with the word elevator. Anytime something's moving vertically, okay, being lifted or lowered, it's an elevator, even if it's not an elevator. All right, so in this elevator question, we have two forces. Okay, we know that there's tension up and there's gravity down. Okay, now it tells me that the mass of the person and the elevator is 600 kilograms. So this is going to be my free body diagram then. Okay, got my rectangle and I've got my mass inside. How do I calculate the force of gravity? They told me what the tension is. They said it's 6,500 newtons. How do I calculate Fg?
The mass of the elevator times 9.8.
Exactly. If you look on your formula sheet, that formula is actually on there. Fg equals m times g. Okay? So that's how we calculate weight, or the force of gravity, because what we're really calculating is the weight of the elevator. Right? So if I go 600 times 9.81, what I'm really doing is going m times g. Okay? And that should be 5886. Pretty sure. Newtons. All right. So now I've got my free body diagram done. I'm trying to find the acceleration of the elevator. What do I do next? Find the net force, okay? Vector sum of all forces. These are the only forces involved. No other forces are mentioned, okay? There's no friction or anything like that. So, okay, this is just a really highly efficient elevator with no friction apparently, okay? And so we're gonna go F net equals the sum of all forces. Force of tension plus the force of gravity, which ends up looking like this, 6,500 minus 5886, okay, which is going to give us 614 newtons up as the net force. Okay. Now I can calculate my acceleration, because in every Newton's second law problem, I use both the vector sum of all forces and m times a. A will equal F net, okay, divided by mass, so 614 divided by 600. .02, we have three significant digits, yes we do. Okay, so 1.02 meters per second squared. Up. Okay. What would the elevator do? Or how would this, let's say I have this question instead. Let me say that the elevator is moving at a constant velocity of 1.5 meters per second up. Same elevator. What is the tension in the cable? Okay, so let's say same elevator. Okay, so if I gave you that question, it would be only 1 or 2 marks. Probably 2. The answer is already on the board. The number that is the correct answer is already there.
Is it 5,886?
It is 5,886 newtons. Why, in this situation, is the tension in the cable the same as its opposing force of gravity? Those two forces are equal. What's my net force? 0. In this situation, my net force is 0. Because what's the acceleration in this question? 0. It's moving at a constant velocity. Okay, that is a set of words you need to always be on the lookout for in a Newton's second law question. Okay, you see the words constant velocity, it doesn't even matter what the number that follows that is. I could have made this 250 meters per second. Would have been a crazy elevator, okay? But it wouldn't matter what the velocity is. If it's constant, there's no acceleration. And according to Newton's first law, if there's no acceleration, it's because there's no net force. Okay? So if there's no net force, that means that this force and this force have to balance. Everyone follow how that ties back to Newton's first law, right? There's no acceleration if there's no unbalanced or no net force. In this case, there is no unbalanced force. There's no net force. Therefore, those tensions have to be equal for F net to come out to 0. Because in this situation, okay, F net equals 0, and it still equals the tension plus gravity. Those are still the two forces that are acting on the elevator. Okay? So it would travel at a constant velocity. This is how the cruise control in your car works. And if you've ever set cruise control in your car, what cruise control does is make sure that the force the engine is exerting forwards is the same as all the drag forces acting backwards. Okay? And as a result, your car maintains a constant speed by maintaining a net force of 0. All right, everyone can understand how that might work? Okay, key words in any Newton's second law problem are constant velocity. You see those words, you are dealing with a situation where the net force is 0, the acceleration is 0, and all the forces balance each other out. Okay? All right, I would like you guys to try number 1. We'll walk through number 2 because number 2 is what we call a differential acceleration problem, which sounds way more complex than it actually is. So, typical elevator question, okay, we just do it like any other Newton's second law problem. We know the mass of the elevator, 600 kilograms. Okay, we're told that now that the upward force is 5,200 newtons, okay, the downward force is still the force of gravity. Is it still going to have the same value as before? Assuming we haven't changed planets, yes. Okay, it should still be 9.81 times the mass, so 5,886. Okay, so what are we noticing about this right now that's going to be different than the last situation?
It'll be going down.
Right. Okay, not just going down, but also accelerating down because the net force is in a downwards direction. Okay, an elevator travels downwards by having the motor not pull as hard as gravity and slowly lower it down as opposed to just dropping it, okay, which is obviously undesirable. Okay, so when we calculate our net force, okay, net force is the vector sum of all forces, so that's still the tension force plus the force of gravity. Okay, so that's going to be 5,200 newtons minus 5,886 newtons, okay, which should give us 686 newtons down this time. Okay, I would have got a negative number in doing that calculation. All right. Now that I know the net force, acceleration can be calculated using m times a. So I manipulate for a. That'll be 686 divided by 600, right, which should give us our 1.14 meters per second squared down. Okay, everybody all right with that? Okay. Now, I'd like you to write down number 2, okay, and then beside it write differential acceleration problem, okay, so that you know the type of problem it's going to be. So if I'm using a chain hoist, is this really still just an elevator? Right? I'm pulling this engine vertically upwards out of a car, right? It's still an elevator. The engine is now the elevator, okay? The chain hoist is now the cable, and what other force is involved here? Gravity, as it is in all elevator questions. Okay? So if I'm drawing a free body diagram of this situation, okay, I have the engine. Problem is, that thing that's supposed to go in the middle of my free body diagram is not given to me this time. I'm being asked to calculate the mass of the engine in this question. So, I got to identify my forces. Okay, there's the force of the hoist, okay, which I'll call FH, right? And then there's the force of gravity. Okay, the other thing they tell me is the acceleration. The overall acceleration, or what we might call the net acceleration, because that's really what it is 1.50 meters per second squared. Up. Okay, and the last thing they tell me is that the force in the hoist actually has a value of 2,850 newtons. Okay. So I know the upward force. I know gravity is pulling down. Can I just calculate gravity? Why can't I calculate gravity? I don't have mass. All right, that's a problem. This is m times g. I don't have m. This formula here also has m in it. And I don't have m, so I'm starting to feel like I might be kind of cooked here because I don't have mass. It's what I'm being asked to calculate, but I don't really have any way to get it, okay? As long as I remember this, though, I can. Newton's second law says that net force equals mass times acceleration net. We never actually write the net, but it's there, it's true, okay? If I look at the formula for the force of gravity, it's Fg equals m times g. Or would actually be written like this: mass times acceleration due to gravity. Okay? Any force can be calculated by taking mass and multiplying by the acceleration that would produce. Okay? So this force in the hoist could also be mass times the acceleration that the hoist would produce if the hoist was by itself. Okay? So any formula that's going to be in a Newton's second law problem can be calculated by taking mass and multiplying by acceleration if you know it. Okay? So if I look at this from a sum of all forces standpoint, I would have this. Would you agree? There's only two forces in this question, the force from the hoist and the force of gravity. They add up to the net force. Everyone all right with that? Well, we've already established I have no way to use that formula because I don't know the mass. Okay? Well, what if I wrote it like this instead? Am I saying the same thing? That's how I would calculate each of those forces individually, right? Mass times acceleration, mass times acceleration, mass times acceleration. What's in every term? Mass. I can cancel it out, right? If everything in that equation is multiplied by the same number, I can cancel it out. Now, a few of you are going, Coderre is like going senile. I'm supposed to be calculating mass right now. How is canceling it going to help me? Well, it's going to help you in just a minute. Remember, this formula right here, I know what it equals. If I can calculate the acceleration the hoist would produce by itself, then I would know 2 out of the 3 parts of that formula, and I could use it to calculate mass. I could work backwards. Okay? So really what we're saying here is the sum of all forces gives you the net force. Well, then by the same token, since acceleration is also a vector quantity, the sum of all accelerations should be the net acceleration. Okay, we add all vector quantities in the same way. So I should be able to calculate what the acceleration of the hoist is because I do know this number, it's 9.81, and I know this number. The question told me what it was, 1.5. Okay, so if I want to calculate this, I'm just going to say AH equals my net acceleration minus gravity. So that'll be 1.50 minus negative 9.81. I have to keep the vector in there, right? Gravity is down, and the other acceleration was up. So 11.31, right? Okay, so then, what that means is, if the hoist was acting alone, if there was no gravity, the engine would accelerate upwards at 11.31 meters per second squared. Okay? That's pretty fast. But now that I know that number, I can take it back up here, and now I can solve for the mass I didn't have. Okay? So I can take that 2,850, divide by 11.31 meters per second, and I'll be left with the mass of the engine, which comes out to 252 kilograms, which is around 500 pounds. Okay? Engines are heavy. Now, here's the good news. We never ask differential acceleration method problems in quizzes or tests or anything like that. But it's important for you to understand that the relationship between the accelerations in a problem is the same as the relationship between the forces that cause them. Okay? So if I can say that F net is the vector sum of all the forces, I should also be able to say the same thing about the accelerations those forces would produce if they were by themselves. Okay? That's all this question is supposed to illustrate, is that accelerations and forces have the same relationship. They're vector quantities. If I add them together, I should get the vector sum. Okay? Everyone all right with that idea? It's kind of a long-winded way to explain that, but. Okay, so this is a differential acceleration problem. See if you can repeat what we just did. Okay, I know I just finished saying I'm never going to ask you one like this, but I want you to try one example so you see it. Okay, skydiver. So they've jumped out of the perfectly good plane. Okay, they're falling. There's a force of friction or air resistance upwards, obviously gravity downwards. Okay, and we want to calculate their mass. Okay, when it goes back in. Okay, so have they already kind of done the free body diagram for us here? Okay, like they have the picture of the person, they have force of friction acting up, that's air resistance. Okay, force of gravity acting down, all right? Since we know that the acceleration of the person is 5.96 meters per second squared down, we know the net acceleration. Okay, we also know the acceleration due to gravity. Okay, and we know that the net force is the sum of the force of friction, okay, plus the force of gravity, and they also told us the force of friction was 250 newtons up. Okay, so these are the things that we know. Since this is true, this is also true. The net acceleration is equal to the acceleration due to friction, okay, and plus the acceleration due to gravity, right? So since I know the force of friction, I also know that that is mass times the acceleration due to friction, okay? Now, if I want to calculate that acceleration due to friction, I just subtract g from both sides. So I've got acceleration net minus g equals the acceleration due to friction, okay? And we're going to have this, negative 1.5, sorry, not 1.5, sorry, negative 5.96. Negative 5.96 minus negative 9.81. They're both down after all. Okay, so they both need to be negative. That's going to give me my acceleration due to the force of friction. Force of habit. Okay, so negative 5.96 minus negative 9.81. Yeah. So we're looking at 3.85 meters per second squared up. Okay, so I know that 250 newtons up equals mass times the number I just calculated, this one here. Right, so now all I have to do to calculate mass, okay, is take the force of friction divided by the acceleration due to friction, 250 divided by 3.85, right, and I'll have my mass. Almost did it again. 250 divided by 3. All right, 65 kilograms is what we get there. Okay, so everyone kind of follow the, oh, I got a few dirty looks there.
Is there a 2 sig-days?
No, there isn't. There are 3 significant digits. $64.9. Good eye. 64, that's a 4. And 64.9 kilograms would be the mass of the skydiver. Okay? Now, as long as we understand that acceleration and force have the same relationship, that's really what we need to get out of these. Yes. Okay. Okay. Number 1 is an elevator question, not differential acceleration method. Try that one. Okay, because a bungee jumper is still an elevator. Okay, because it's vertical. There's a force up, hopefully, the bungee cord, okay, and a force down, gravity. At the bungee jumper question. Okay, so we have our free body diagram that we want to draw first off. 55 kilograms in the middle. Okay, obviously there is a force of the bungee cord, okay, that is acting up, and a force of gravity that is acting down. All right, and the force of gravity we can calculate because we know her mass and we know the acceleration due to gravity. Okay, so if we go 55 times 9.81, we'll get 539.55 newtons. Okay, they tell us the force in the bungee cord is 825 newtons. So what is she doing? She's moving upwards. This is after the bungee cord has been stretched as far as it will go, okay? Or it is stretched as far as it will go. She's accelerating upwards at that point because she's actually slowing down, okay? She's accelerating upwards because the bungee cord is slowing her fall, all right? All we know is that the bungee cord is really stretched because it's exerting a great deal of force upwards, which is, of course, what you want it to do, okay? Can I calculate my net force now? Well, I got the 2 forces that are involved. F net's the vector sum of all forces, force in the bungee cord plus the force of gravity. So that'll be 825 minus 539.55 should give me my net force there. So 285.45 newtons up. Okay, I should be able to calculate her acceleration by taking my net force that I just calculated and dividing it by her mass, 55. So 285 divided by 55. And we should have an acceleration of 5.19 meters per second squared. Actually, we only have 2 significant digits, 5.2. okay? Meters per second squared up. Okay, that is a pretty typical elevator question. Okay, and you're gonna get those on your quiz on Thursday, for sure. All right? All right, good job today, guys. Hello.